Graphing a linear equation by making a table of ordered pairs. Make a table of ordered pairs and sketch the graph for 3x minus 2y equals 6. The first thing we're going to want to do is look at the equation we are given, and we're going to solve the equation for y. When we solve an equation for y, we want to first look at where the y is located, and we want to isolate that term first. So in order to isolate that term, I'm going to have to subtract 3x from each side. So when I subtract 3x from the left, it will cancel out. I will be left over with negative 2y equals negative 3x plus 6. I'm getting in the habit of writing the x term first and the constant second to help us out with the next section. Now that the y term is isolated, the next thing we have to do is isolate the y itself. And we will notice that the y is attached to the negative 2 by means of multiplication. So in order to isolate the y itself, we're going to divide both sides by negative 2. Now when I divide both sides by negative 2, one of the tricks that you're going to find that will help you out is to look at the negative 3x plus 6 and divide each term by negative 2. So when that happens, negative 2 divided by negative 2 will give us 1y. Negative 3x divided by negative 2 will give us 3/2 x. And positive 6 divided by negative 2 will give us negative 3. And I would like to point out that we don't actually divide the numbers where we see the coefficient of x. A lot of times we just want to simplify by making sure the answer is going to be positive or negative, and we really just leave it in fraction form. So now that our equation is solved for y, it'll make it easier when we plug in values of x to find a corresponding y value to get an ordered pair. After you've solved the equation for y, your next step is to make a table. And when I make a table, it's going to help me organize my information as I find it. So my table will include the x values that I choose, the y values that I'm computing, and we find the y values by plugging the x values we choose into the equation y equals 3/2 x minus 3. The last column of my table will help me tie everything together, where I'm going to pair up my x value with its corresponding y value. So if you take notice of how our equation is set up, you'll notice that the x is multiplied by a fraction with a denominator of 2. And while we can choose any x value that we would like, sometimes we prefer not to get fractions or decimals. So we can kind of be smart about picking our particular x values by choosing values of x that are multiples of 2. So just so that we are clear about what multiples of 2 are, remember that multiples of 2 are the product of 2 with any integer. So a couple of good values to pick to choose for the x would be 2 times 0, which is 0. That'd be a good one. 2 times 1 would also be great. 2 times 2, which is 4, would also work nice. And a lot of times I like to throw in some negative values of x to help me out as well. So maybe I'll look at 2 times negative 1, which would give me negative 2. And 2 times negative 2, which would give me negative 4. You're welcome to choose more multiples of 2 to fill in for your x. But really, I believe if we have this many x values, 0, 2, 4, negative 2, and negative 4, that'll give us enough ordered pairs to see the pattern so that we could actually draw our line. So let me just lengthen the lengths of the columns. And I'm going to start with plugging in 0 to my equation, y equals 3 halves x minus 3. So I try to keep myself organized. You might see me showing a bit of work off to the side. When x equals 0, we already know that y equals 3 halves x minus 3. We would be plugging in, instead of x, we'll plug in 0. And then we'll compute our answer. So 3 halves times 0 is 0. We still have minus 3. So 0 minus 3 is negative 3. So my corresponding y value, when I plug x equals 0, I will get y equals negative 3. So I'll fill in my chart. And then I'll finish off with my ordered pair. Remember that x always comes first. So we're going to have 0, negative 3. We will continue plugging in the x values that we chose into our particular equation involving y, so we can find the corresponding y values. So the next value of x I have to choose. What happens if x is equal to 2? I'll plug that in. So it's going to be y equals 3 halves x minus 3. Substituting x equals 2 in, subtracting off 3. You'll notice then when you multiply 3 halves times 2, we can always put the 2 over 1 so that we can cross cancel. And you're going to notice that the 2's will cross cancel. 2 divided by 2 is 1. So you are left with 3 times 1, which is 3. We're still subtracting off 3. And we're going to get 0 as our y. So when x is equal to 2, y is equal to 0. And our corresponding ordered pair is 2, 0. We'll continue with x equals 4. Keeping in mind that my original equation is at the top. So I'll plug this in. Y equals 3 halves times 4 minus 3. And again, because you're multiplying a fraction with a whole number, it's always kind of nice to put the whole number over 1 so that you can help yourself to see if you can cross cancel. And I notice we can. 2 and 4 have common factors. 2 goes into 2 once, 2 goes into 4, 2 times. Now what happens, you will have to multiply the remaining numbers. So 3 times 2 will give us 6. And we cannot forget that we're still subtracting off 3. So 6 minus 3 is 3. So when x equals 4, we get a y value of positive 3. And our corresponding ordered pair is 4, 3. We will also want to finish our table by plugging in the negative values of x into our equation. So I'm going to write that on the side as well. When x equals negative 2, our y will equal 3 halves times negative 2. Notice I'm enclosing the negative 2 in parentheses, and we still have to subtract off 3 from the equation. So what you want to pay attention to here is that you have a positive number times a negative number. So now we want to be careful when we multiply a positive number times a negative number, we will get a result that is negative. So I'll write that in to remind myself. And also, when I multiply a fraction times an integer, I could always put the integer over 1, which allows me to understand how I can cross-cancel. So I can still cross-cancel because I noticed the 2 in the denominator has a common factor with the numerator. So 2 goes into 2 once, and 2 goes into 2 once up here. So I'm going to multiply 3 times, it would be negative 1. So 3 times negative 1 is actually negative 3. And we can't forget that we still are subtracting off 3. So we're going to get a corresponding y value of negative 3 take away 3 is negative 6. So when x equals negative 2, y equals negative 6. And again, we're going to put those together in an ordered pair, negative 2, negative 6. Now the last thing we're going to do is plug in the x equals negative 4. Again into our equation, y equals 3 halves times negative 4. Then we're going to subtract off 3. Keeping in mind that when we multiply a fraction times an integer, we'll go through the whole process of cross-canceling again. 2 goes into 2 once, 2 goes into 4 twice. And we have to be very careful because we still have a negative integer right here. So 3 times negative 2 is negative 6, and we're still subtracting off 3. So negative 6 minus 3 is negative 9. So when x equals negative 4, y equals negative 9. So the last thing we're going to do is rewrite that ordered pair, negative 4, negative 9. And we're now ready to plot these ordered pairs on a set. So now we refer back to our table and look at the ordered pairs that we have created. And we're going to plot each ordered pair on the axes over here. So the first ordered pair I'm going to plot is 0, negative 3. And when I'm going to plot 0, negative 3, that means I start at the origin and I do not move left or right, but I move 3 down. So we should have a plot right here. Plotting 2, 0, that means I'm going to start at the origin and go 2 to the right and don't move up or down. So I should have an ordered pair at 2, 0, that's right here. I'm also going to plot 4, 3. That means if I start at the origin, I'm going to go 4 to the right and 3 up. Be able to plot that right there. So 4, 3. And you're starting to see a pattern. The dots appear to be falling in a straight line, and that's exactly what we want to see. To finish off my problem, I'd like to plot negative 2, negative 6, and negative 4, negative 9. So plotting negative 2, negative 6, we're going to start at the origin and move 2 units to the left and 6 units down. So negative 2, negative 6 will fall about right here. And plotting negative 4, negative 9, we're going to start at the origin, move 4 units to the left and 9 units down. So we'll see we'll get a point right about here. And one thing you want to make sure of when you are picking your ordered pairs and plotting them, you want to make sure that you're seeing this pattern that they are falling in a straight line. If at any time you notice you see some of them in a straight line and one of them's a little bit off, you're going to want to go back and check your math. Check to see if you have made all of the correct computations, you didn't miss any negative signs, and that's a good indication. So the last thing you're going to want to do is connect your dots. Keep in mind that these 5 points that we have plotted only represent some of the solutions to this linear equation. In fact, there are many more points along the line that will satisfy this equation, and pretty much that's what a line is. It's made up of an infinite amount of ordered pairs. So let's make sure that we connect our ordered pairs with a straight line. And you're going to want to notice that I extended the line all the way through the edges of the axes. So we have just finished graphing the line. 3x minus 2y equals 6, or its equivalent, y equals 3 halves x minus 3.